One strategy is to take everything that you need with you for the block, not the class, but the whole block. So first block, you have language arts and math. Take all that with you. Your math book now is up to you what you do with it. And I need it back at the end of the year, so don't take it home and feed it to your dog. But you can keep it here in my classroom if you want. But I'm not responsible for it. You can keep it here in your locker. That's a better idea because I'm not going to keep track of your books back there. Or you can take it home. If you don't always have internet or if you have to fight your brother for the computer or something, take your book home so you have it at home. And then just have a different book here, like one of your teammates. You really only need one book per team. Guys, you got cards back there. I'll tell you where to go. Sorry, we don't need cards. So you're right here, and like that, you're 10, so you are... Alright. One big thing that I want to make sure we're going to use as we move forward.
Which book is this in?
It's always CC2 unless I tell you otherwise.
Okay.
So we spend probably either 60-40, 70-30. Most of our time is in the CC2 book. Because I have some people still resisting. Oh, I should probably unfreeze this. Resisting writing this down. In your plan book, exactly what I have in the box. You cannot just write 1, 2, 3. You cannot just write CPM. You cannot just write math homework. That's pointless. It needs to be exactly what I have. And guys, so the flip side of that, it's going to bite you in the butt if you don't, because later when we do a next organization quiz, we're looking for exactly what we had written on the board, and if you don't have it, you fail the organization mastery. So if you're thinking oh, I'm going to work the system, no one will know, yeah, we will. Just play along with us. This stuff, always in this area, please pay attention to it, but then I just had Math 7 leave the bags out for you guys. So hopefully your group already has a new bag. And then we're going to dive in. So head your notes, please. We are in 1, 2, 3. And this is the title of our lesson. So modifying sample space is actually what we would head our title with. And honestly, we could just label it sample space. Now I bet most of us don't know what sample space is yet, so we're about to find it out. Any volunteers for reading? I always end up calling on Quinn. You guys fight each other. Mallory, you can read. As soon as you pass out the cards, I'll let you read as my appreciation. So just this first, I'll slide it down.
If you want to have the best chances of getting a red gumball from a gumball machine, is it better if the machine is full of gumballs or half empty? How do the chances of getting an ace in a deck of playing cards change if you have 3 or 4 decks of cards to choose from instead of only one deck? In this lesson, you will think about the size of the sample space, the collection of the possible outcomes of an event. Think about these questions as you work today. How has the whole or total changed? How has the portion or part we are interested in changed?
So sample space is this really important word when we talk about probability. I'm going to give you a super easy way to write it in your notes. So in your header, you probably just wrote sample space, but we need to know what this is. So again, write sample space, and if you do anything to notate vocab, this is really like a vocab word. Sample space, 3 words to define it. All possible outcomes. Now I need your guys' help. We need to modify the bag that you have at your desk because I did not want to give you guys 2 separate bags. I thought that would be pointless. I need you to fix that bag and set it up so it has 1 yellow, 2 red, 4 green, 5 blue. Modify your bag to make that happen. then, please number in your notes that we are on 75. So you can do 1-75, or you don't have to write the. Oh, hi. That was awkward. Now, I'm going a little bit rogue. First thing we're going to do, I need your group to determine in this problem, what is our sample space? In this problem, so what I'm asking you is list all of the possible outcomes. And this is not very hard, so if you immediately think like, oh my gosh, this is easier than you might think. So talk in the group, what are all possible outcomes with our bag now? Time to use cards. Alright, I can't shuffle because we never made it all the way through last week. The one that you just said. Well, actually both groups should be identical right now.
Yeah, they are. They're the same.
So Gwendolyn, I'm just using cards, so it's just gonna be. So Gwendolyn, how many different outcomes are there? 4, right? What are they? So our sample space is red, green, blue, and yellow. Who thought that the number of blocks mattered? I would have. Sample space does not ask what are the chances. It does not ask how many are there. It does not ask what's likely and what's unlikely. It just asks what's there. We've got some red, some blue, some green, some yellow. That's all we care about. Then, when we talk about the actual probability, we care about the numbers. So I want your group to work through, and I'll scroll, and some of you might get like confused, which is great because that's my job. Now, we need to appropriately write these out. How do I appropriately write out a probability? Savannah, how do I notate that in my paper?
You have,
What do I physically write?
write P parentheses,
P, parenthesis, what goes on the inside?
like, letter or...
What I'm looking for, right? The event that I'm trying for. So like probability of red. Please write this down because your group is about to solve these. Then probability of green. You don't have to color code, but I like it when I can. Probability of blue. And then probability of orange.
It's yellow. But it's
Orange. Orange. I did not stutter. Orange. I'll give your group 2 minutes.
There are 12 blocks, and you just put the amount of
You do not need to reduce, you do not need to convert, all we're looking for is fractions. So if I want to give a bit of advice, start putting your fractions vertical stack as opposed to like diagonal stack, just because it'll make your brain easier, or it'll make things easier for your brain. We start doing fraction, multiplication, division, all of those, it's easier for your brain to see this over that as opposed to like, yeah, just if I were to give you a bit of advice. Hey guys, I'm seeing both as I walk around the room, so I want to give a tiny bit of advice for us. Your brain will have an easier job of reading a fraction that looks like this compared to a fraction that looks like this. This is much easier for where we are about to go. So my advice is always write your fraction vertical stack as opposed to diagonal stack. This is better, right? It's not right versus wrong, but this is better. Well, it's not. It's the one's not wrong. It's just harder. Like for your brain, there's research that shows how your brain works. All right, random cards. Love it because I don't even have to think. Gabe, our probability. Now you guys all moved. Gabe, probability of red. Dang it! Why do you look so much like a Gabe? Gabe, and you don't look like a Gabe for some reason. You're offended? I don't know what you look like, but I'll figure it out later. You look like a student I've had before, and his name was not Gabe. That's why my brain is getting broken. All right, Gabe, red. Now, I agree, but if we write it exactly how it's in our bag, the first thing we would have written would be 2/12, right? Then we can reduce. So if you had 2/12, perfect, you're great. You can leave it right like that. But Gabe reduced by cutting the top and bottom in half. Which, if that is a struggle for you right now, we might want to talk, we might want to do some extra practice. If like cutting the fractions in half to reduce or doubling them, make them bigger, if that's a struggle, we should probably talk and get some extra practice on that. Because we're going to skip some lessons. We actually skipped the next like 3 lessons in the Math 7 book, so tomorrow we're going to jump to 1 through 7. So be aware, like that's the compressed timeline. Probability of green. Connor. 1/3? How'd you get there? Give me what you started with first. Yeah, 4 green over 12, which then can reduce to 1/3 because you cut everything down by 4. Or 8/4. Probability of blue. Teak. 5/12. Can this be reduced? No. And class. The probability of orange? 0. Now we can still put it over 12. A 0 in the numerator is okay. 0 in the denominator is a no-no. Now, if we think about these probabilities, are these experimental or theoretical, and why? Talk with your group. I'll give you for about 45 seconds. Now, here's what's up. Here's the real reason I'm doing this. This was in your homework. At this point, you should know the difference between theoretical and experimental. If you don't, that's on you. Now, like, I'm here to help you, but it was in your homework. So if you actually cared about your homework, you should be aware of it, and we also talked about it last week. If between your whole group you can't figure it out, it's not good. Because if I gave you guys a homework quiz today, and this was on last week's homework, I can quiz you on it because you should know it. So if your whole group can't figure this out, you might want to like analyze, am I doing my homework with enough attention to it to learn what I'm supposed to be learning? You don't just learn in class. You will learn from your practice work this year, like without me. So with your group, I'm not answering any questions right now. With your group, take about a minute. Decide, was this theoretical or experimental, and why? And I'm going to random call them something different. Okay. No. Are there any orange? There are no orange.
Oh, I thought you
No. Like orange. Like literally. Like if they told you.
Orange and you had to make do with
No. If they told you the grand prize. Guys, let's be really clear. Those yellow blocks are yellow.
Yeah.
I was asking orange intentionally because it doesn't exist. So this wasn't a typo. I'll show you really what we're dealing with. It's not that I didn't have orange blocks. I have plenty of blocks of every color. So when we do this stuff in class, take it for exactly what it is. I was asking orange because it doesn't exist. And they told you, like, the grand prize is orange. Great, the game is rigged. There are no oranges, right? We can't win. All right, so what do you think? Theoretical, experimental? Take another 30 seconds because we interrupted you. Kate, and this one's coming to you. This one's coming to you. You guys talk. Do you know what's up? What? Well, sorry, Sheila. Okay, one, I'm still really bad at this, so wait, who are you? Okay, me moving you guys around has totally just broken my brain. I should not have done this. So please, if you guys can't, if you don't have it with you today, don't worry about it. But your name tense. Now that I've moved the classroom around, my brain is broken. I have goofed up everything, and we had 3 days away from each other. Sorry. So Peyton, did your group decide on something? You decided it was theoretical. How did you make that decision? All right. Shh. Exactly what Peyton just said is like exactly what we should have all thought about. Say that again. We did not do an experiment. We did not actually try this. We did not pull any blocks. All we did was look at it. So this is theoretical, which in your homework, if you came and asked me, I told you just put T or E. You don't have to write out the whole word. I don't try to put like a T and E so that you can like get away with it. I'll just mark it wrong. Theoretical, we didn't do it, right? To be experimental, we have to actually do something. So, question for you. What would happen if I want to make sure I'm not skipping things too far, I'm vamping for time a little bit. Good. I was about to forget about this question. We're going to make predictions about blue. Okay, so go ahead and in your notes, like, put that we're doing 76. Go ahead and we're moving on. 76. Using the bag as it was, as you guys just set it up. If we draw, because a draw, talking like mathematically or probability, is like a trial. It's a run. It's like a test. Right? So if we draw 12 times, how many blues do you think we get? Ouch. Hold on. So make that prediction. Then if we do 24 draws, how many blue do you predict? And why? What about, now this, I'm going rogue, right? This is not even in the textbook. What about 100? So talk with your group, make these predictions. I'll give you, I don't know, like a minute. Don't know what that word is. Well, so I try not to write in cursive, but I'm so used to like you can just drag through some letters and my hand gets confused because my brain. All right, talk with each other. If we draw 12 times, or 24, or 100, what's your prediction of how many blue would be the results? And this is not going to be a daily thing. If you can't manage yourself to do what you need to do, we need to have a conversation. Okay? Marin, this is going to come to you. You ready to talk about this? Your card's just next. So, like, if you're going to pass, just tell me now and I'll keep moving on. Okay, I'll give you like another minute or so. see if I send one of these questions your way. Are you able to help it out? Your card's up. That's one. Yeah, yours. I'll just put the card back in your hand. Yeah, we put them back. Like after every draw, that's a really good question. I was gonna wait and see if anyone. Now it tells you up here. So you draw 12 times. Each time you draw, you put the block back in. So that's called replacement. Or there's trials where we can do non-replacement. So if you've ever been to a casino, which you probably haven't, but at the tables, they will play blackjack or different card games where they shuffle like 4 or 5 decks together, and after the play happens, the cards are gone. Or other tables put them back in the deck and shuffle them back together and they restart. So there's with replacement and without replacement. There's a strategic reason why they do that or why they don't do that to help that house win. Like they're trying to make the games in favor of them. All right. Marin, do you have a prediction for if we draw 12 times?
Yes.
What do you think?
See, I was debating 5 or 6 because I wasn't totally sure.
Now, why were you debating?
Because I wasn't totally sure.
What made you debate between 5 and 6 as opposed to like 18 and whatever?
So there's like more blue than there is the rest of the colors.
Okay.
So I was just thinking it's probably more likely, but then I was also thinking it's less likely because there's more blocks than there are blue.
Wouldn't there always be more blocks than there are blue?
But like there's
Unless
more
like they're all
other
blue.
blocks.
Okay. So we're more likely to get a not blue block, but sometimes we'll get blue, right? It's just not as likely. So if you said 5, is that more than half or less than half? Less than half. If you said 6, that is half. Are half of our blocks blue? No. Now, we could potentially get 6. Maybe. But based off what we have, we are going to predict 5. Right? So, then, George, what about if I do this 24 times?
You get, well, from the past prediction, 12 times 24, just times 2, so you get 10.
So I'm going to predict 10. Now this is tricky. Is there any volunteers for the next one? George, I'll stay with you.
Okay.
What about going to 100?
For 100, so 24 is close to 100. So I did, so 25 times 5 is, not 25 times 5. 25 times 4 is 96. And that's close to 100, so I said around 40-ish.
40-ish. I like it. I use the postfix. I have no idea what you call it. I use ish a lot, actually. Now, in math, there's a nicer way to write 40-ish. In math, we do the squiggly equals, and that means equals close to 40. Now, this is not a fraction. Let me make this very, very clear. This is not a fraction. This is just me rewriting another option for how to write 40. I mean, I hope that's clear, but I just have to say things like that so no one gets confused. Now, if we were to be really particular, 24 times 4 doesn't actually get me there. So if I want to be super particular, I can do 100 divided by 24. I'd actually have to multiply by 4.16, and the 6 goes on forever. So if I do that times by 10, this actually comes out to be 41.6, which is closer to 42. But this is still close. It's still a good approximation. But if we're being exact, it'd either be 41.6, and we can put a repetend on here. But you can't actually get 0.6 blocks, right? So this would be if we were being exact, but this would be if we were being realistic. So there's a difference in probability of this is what the math tells me, and this is what can actually happen. Any questions on this? Because the next part we're going to go kind of quick on, because I think this should make sense to us. Put all your blocks in the bag. All of them. Every single block. So, you're at the casino or wherever. I need to make a good name, maybe like the Kid Casino or something like that. So you're somewhere playing these games, right? And so they were telling you, like, here, this game's better. Try this one. So I'm just trying to make up a story to make this interesting. So, you go from the game that you were just playing, right? You walk over here, new game, right? New bag, new game. And they tell you, look, this is a totally different game. Everything has changed. So much more going on here. We've doubled the blocks, so your chances of winning are doubled. And you scratching your head for a second. They've doubled the blocks, so my chances of winning are doubled. So let's say yellow makes you win, right? Because we didn't even talk about it last time. Yellow makes you win, because there's not very many of them. Talk with your group. Does doubling all of the blocks double your chance of winning? If not, how can you explain it then? What could we write? What could we show? Yeah, try it out. Take a minute.
Say if we just add the exact, like, this was our layout, and we had 1, 2, 4 days. Then add doubling it, we just need 5 12. That's 12. And 4. Exact same thing as 5 12. Double fraction. Yeah. I don't think
All right, bring it back together. Now we're going to talk about that in a moment, but not right at this minute. So because we didn't talk about yellow last time, we'll save that for a moment. If I talk about blue, so let's write this out appropriately, P of blue. I want you to start with exactly how it states. Exactly the situation. I know a lot of us can reduce fractions, we're good at that, but start with exactly what you see. Then, what about red? What about green? What about yellow? Notice we're not going to talk about orange this time. We've wised up. I'm going to write it in black, though, because yellow is really hard to see. So, Connor, the first time through, we asked about probability of orange, although it didn't. Oh, yeah, sorry. I'll try to, stay close to the board. So, probability of blue that we see right now. Caitlin, what do we have up there? Actually, take a second. Phil, finish this out. I'm curious. And I don't know how far I want to extend this. I need my book out. Forget how much further we have. Yeah, we're okay to do this. Take a moment on your own and just write down all your probabilities. Do that on your own real quick, just so you have it done. If you can make it a percent, do that. What did you say? 1/12? That you might need a calculator for. So we already said that there's 10 blue now, right? And if we reduce that, so actually, I'll take a volunteer. Anybody want to talk about what has happened now that we've doubled all of our blocks? Quinn, what's happened?
The blocks are doubled. That's really the only thing that's actually happening.
So aside from more blocks, So Quinn is saying nothing changed. Like aside from the number of blocks, nothing changed. Why? George?
Because you're just, like you said, you're just doubling everything. There's not, you're doubling your chances of winning with yellow, and you're doubling your chances of, like, losing with every other color. So there's, and with just doubling everything, you can reduce it back to the original.
If I double again, and I make 20 blues, and I double everything else, and I make 4, is this a different fraction? Not really. It looks different, it uses different numbers, but it's the same. And no matter what I do with this fraction, it would end up coming out to be approximately 42%, right? If we round, those go to be equals. So my red, no matter what we do there, and actually I might skip on past this, but I think we probably get it. If red, we double the amount of red and double the total, that's going to become the same percentage, same probability. Same with green, same with yellow, same with orange. Orange is still 0. We double 0, you still get 0. Does this make sense to us that what we've done to the fraction doesn't actually change anything, aside from what the numbers are? Any questions? Yeah, we're going to skip on through this. So this is a pretty straightforward question. What if I had, now I'm going to ask it differently. What if I had Jesse's group and George's group combine their 2 bags together? Does that change anything? No, it just keeps making more and more and more. There's a lot of times in the world where this happens. The group gets bigger, but because everything else stays consistent, it doesn't actually change the probability. Honestly, because of how fast we move and everything else that I'm going to expect from you guys, I want the next 10 minutes just be time for you guys to be able to work on your homework.
Cool.
So go ahead and dive in. By the way, this is a really useful math notes box. I'm going to slide it down onto this screen for a minute. If you are at all confused about probability, this is even worth putting a post-it note in your textbook on this page. This is everything having to do with probability, all in one math notes box. So outcome, what you're looking for, or possible options. Event, when you do it, you're looking for rolling a 2 or spinning a blue or whatever. Sample space, every possible outcome. Then the probability. And you don't need your book, guys. I'm going to show it to you up on the screen. So here's 80 and 81 if you want, right up on the screen there. And then I'm going to collect your guys' cards here in just a moment. And I'm going to stop the video, I think.